Example 6. Out of the textbook, example 6 is going to be one where they're going to show you how you can manipulate the left side and then manipulate the right side, because if I said which one of these is more complicated, they really both are pretty complicated. So it's going to be hard to make one look like the other. We're actually going to try to make one look simple, and then we're going to take the other one and we'll be able to make it try to match the left side. At any point for what we're doing, all of the homework that I'm going to assign, we're going to just do the left side. We're going to be able to do the left side. And on this problem, you still could do the left side. I'll do the whole problem the way they do it in the textbook, then I'll back it up and show you how we could have taken the left side all the way and got that crazy looking answer over there on the right side. But let's start out with kind of what they did. Okay, so you have cotangent squared theta over 1 plus cosecant theta, and then you have 1 minus sine theta over sine theta. So the first thing I see is the cotangent squared theta. Cotangent squared theta, what I can do, I'm going to use my identities. The third Pythagorean identity says this: 1 plus cotangent squared x equals CSC squared x. Well, that means, cotangent and cosecant is somehow related. So what I'm going to do is I'm going to manipulate this one so that I got cotangent squared x equals CSC squared x minus 1. So I'm going to take, anytime I have a cotangent squared, I can turn it into a cosecant squared minus 1, which is what the first thing I'm going to do. So first thing, I'm going to change this to CSC squared theta minus 1 for 1 plus CSC theta equals 1 over, nope, that's not right, 1 minus sine theta over sine theta. So that was my first step. Cosecant squared theta minus 1 over 1 plus cosecant theta equals this over here. And now this is going to be one of the first times we can use one of these things I've said here. Look for opportunities to factor, add fractions, FOIL, conjugate, split a fraction. You might not know where to go from here, because you have cosecant squared minus 1, you got 1 plus cosecant. No, because of these plus signs, this won't cross off with that. That's not how it works. But one thing is, that numerator right there, this numerator here, that is a difference of squares. That is a cosecant squared minus 1. And if you remember difference of squares, say that you have x squared minus 4, that's a difference of squares. X squared and 2 squared. The pattern is those things can be factored to say x plus 2, x minus 2. Or vice versa, x minus 2, x plus 2. That's the pattern for difference of squares. So what you have on top is a difference of squares where you've got cosecant squared minus 1. I can split it into two binomials. The first one being CSC minus 1, and the second being CSC, let me put my thetas in there, theta plus 1. CSC theta, or cosecant theta minus 1 and cosecant theta plus 1. And then at the bottom I got 1 plus CSC theta equals 1 minus sine theta over sine theta. Now here's the thing. The bottom of the fraction says 1 plus CSC theta. These two binomials do not say 1 plus CSC theta. But if it's adding, it can't be subtracting. The order doesn't matter. If it's subtracting, it does. But so this CSC theta plus 1 is the same as this 1 plus CSC theta. I promise you I could just rearrange the bottom. If I could write CSC theta, nope, can't write. CSC theta. I could have done that. The reason is I want them to be identical. If those two are identical, the binomial here in a parenthesis and the binomial here in a parenthesis, I can cross it out. That leaves you with just CSC theta minus 1 equals 1 minus sine theta over sine theta. Okay, and at this point, this is where the textbook says, okay, you've got this simple. Now take the right side and see if you can make the right side look like the left side. So from this point right here, we will come back to, and I will see if we could have kept going to make this left side look like that. But we want to go along with what the textbook said. You're allowed to change the left side to a certain point, and then you can turn around and start manipulating the right side as long as you keep the left side the same. So here's what we're going to do. We're going to write the left side the same. The right side, well, notice that the right side's a fraction and it's one piece. Well, this is going to be easy for us to split into two different pieces. Because this is two different pieces. So what I'm going to do is, I'll even draw my little arrows here. Split it into two fractions. If you have two pieces on top and one piece on bottom, you can split it into two fractions where you go 1 over this one, subtract sign in the middle, and then sine over or sine. So I'm going to make it 1 over sine theta. The subtract sign now goes in the middle, and then I have sine theta over sine theta. All right, so then the next thing, I'm going to just rewrite this again. Theta minus 1 equals, well, heck, that right there turns into CSC theta, just like I have here. So this turns into CSC theta. There's that minus sign, just like there's that minus sign. And that right there, sine over sine, turns into 1. And the left side looks like the right side. It's probably as easy as it gets. It really, we worked the left side down, and then we only had to take 2 steps to make the right side look like the left side. That's about as easy as we could get. I'm going to back us up. So take a look at it real quick, see what happened. I'm going to back us up. Say that you didn't see that, or you didn't think about that, or you're just dead set on taking the left side all the way. How can we make the left side look like the right side? Well, the left side has CSC in it, and the right side has just sines, a couple of them. So one thing we could think is, all right, CSCs, cosecants and sines are related. I'm going to try to get some sines happening. So I'm going to turn this, or using the advice of, hey, turn everything into sines and cosines when you have nothing better to do, turn this into 1 over sine theta. Minus 1 equals 1 minus sine theta over sine theta. All right, now I have a fraction and I have something that's not a fraction. And if this has everything together as 1, this is all, it's a fraction, but it's as 1. This is two separate things. So what I'm thinking is go back to the thing of, hey, let's add fractions. And you might be thinking, I don't see fractions, I see one fraction. You do see one fraction, so let's turn this into a fraction here. And then we can get them together if we get the bottoms the same. So how do we get the bottoms the same? Remember, they have to have the same bottom. So you take this denominator and put it here and here. And technically, you would take this denominator and put it here and here. But if it's a 1, don't worry about it. 1 doesn't do much. It does a lot and nothing at all at the same time. 1 over sine theta minus, this now becomes sine theta over sine theta. Sine theta over sine theta equals 1 minus sine theta over sine theta. Well, heck, hopefully you can see where we're going with this. You have two fractions with the same bottom. When you put them together, it's going to look like that. These will go together to make 1 minus sine theta. 1 minus sine theta. Notice that if there was more than one piece over here, you'd have to apply that minus to all of them. Then the bottom is just sine theta. And you are done. 1 minus sine theta over sine theta. So really, we were about here. It took 1, 2, 3 steps. You could have done it working all the way down the left side if you knew what to do. If you didn't, you could have worked the left side down and said, well, I'm stuck. I'm going to see if I can do something about the right side. And then that's it. That's example number 6. Remember, look for opportunities to factor. Look for differences of squares that you can turn into two binomials. Sometimes that helps. Sometimes it doesn't. Look for opportunities to add fractions together or split fractions apart. FOIL, conjugate, all those things. And when you're lost and you don't have anything better to do, turn something that's not a sine or a cosine into a sine or cosine. And then get a clue. Go, oh, I have this fraction and this non-fraction. Maybe I can get them together into be 1. And it just kind of worked itself into place here. All right, so that concludes example number 6. Hope that was